August 1918. A British machine gun crew holds a position in the ruins of a stone farmhouse near Amiens, facing a German counterattack. About 800 infantry advancing across open ground, roughly 400 meters away. The crew is operating a Lewis gun, an air-cooled light machine gun weighing about 12 kilograms, firing .303 British ammunition from 47-round Pan magazines at a cyclic rate of around 500 rounds per minute. The gunner has already prepared 32 loaded magazines, stacked within arm's reach. The assistant gunner has 4 spare barrels, and he understands the weapon's critical limitation. The aluminum cooling shroud surrounding the barrel can dissipate heat from about 12 magazines of continuous fire before the barrel temperature exceeds safe operating limits. Beyond that point, accuracy starts to drop, and catastrophic failure becomes, well, probable. The crew has learned through experience that disciplined fire control and methodical barrel changes allow sustained defensive fire far beyond what the weapon is supposed to handle on paper. Over the next 40 minutes, this two-man crew will fire more than 10,000 rounds, change barrels 6 times, and inflict casualties estimated at 200 men, forcing a battalion-strength assault to withdraw without ever reaching the British line. And here's the thing. The weapon that enabled this kind of disproportionate defensive effect wasn't superior to German machine guns in rate of fire, or range, or reliability. It worked because of how it was used, because the crew exploited its specific technical characteristics and compensated for its limitations. The British Army in 1915 faced a defensive firepower problem, both doctrinal and mechanical. Standard infantry units lacked organic automatic weapons capable of sustained fire against mass attacks. The Vickers medium machine gun was effective, no question, but it was heavy, over 50 kilograms, once you include the water, the tripod, and the ammunition. It needed a crew of 6 to 8 men, and it wasn't easy to reposition, especially during fluid defensive actions. What infantry platoons actually needed was a portable automatic weapon, something individual soldiers could carry and operate, that could deliver sustained suppressive fire and be moved quickly between firing positions. Existing light automatic rifles, like the French Chauchat, were unreliable and had a limited magazine capacity. The Lewis gun, adopted from an American design in 1914, addressed those requirements through mechanical simplicity and innovative cooling technology, though its effectiveness depended entirely on crew discipline and understanding its thermal limits. Mechanically, the Lewis gun operated on a gas-actuated system. When fired, a portion of propellant gas was diverted through a port in the barrel into a gas cylinder positioned underneath. That gas drove a piston rearward, rotating and unlocking the bolt. The bolt moved backwards, extracting and ejecting the spent case, then returned forward under spring pressure, stripping a fresh round from the Pan magazine and chambering it. The rotating bolt locked into the barrel extension, and the firing pins struck the primer. The cycle repeated as long as the trigger was held and ammunition remained. Cyclic rate sat at about 500 rounds per minute, lower than many contemporary machine guns, but adequate for sustained fire rolls. Muzzle velocity was roughly 744 meters per second. Effective range was listed at 600 meters, though in real combat it was usually under 400 meters because of the open sights and bipod mounting. The defining feature was the aluminum shroud around the barrel. It created a space around the barrel, and when the weapon fired, the barrel heated up, creating convection currents, drawing air in through vents at the rear of the shroud, circulating it around the barrel, and expelling it through the muzzle. It was passive air cooling, more effective than simple exposure, but not as effective as water cooling. The system allowed sustained fire, but only within limits. After about 12 to 15 magazines, the barrel could reach roughly 400 degrees Celsius. At that point, accuracy degraded as the barrel's metallurgy was affected and headspace tolerances shifted. Push it past around 18 magazines, and barrel failure became likely, either warping or outright rupture. So doctrine mattered. Crews were trained to fire in controlled bursts, not long continuous streams. Magazine changes created natural pauses, and those pauses mattered. The standard technique was about 6 to 8 rounds per burst, with 2 to 3 second intervals. That brought the effective rate of fire down to around 120 rounds per minute, but it massively extended how long the gun could keep working. Barrel changes were done after roughly 500 to 600 rounds, or when overheating signs appeared. With a trained crew, the change took about 30 seconds. The hot barrel came off, set aside to cool, and a fresh one went on. Simple, but only if everyone stayed disciplined. Testing at British small arms schools showed something interesting. Proper barrel rotation meant sustained fire could continue indefinitely, limited only by ammunition supply. With 4 spare barrels, a crew could maintain continuous fire for over an hour, cycling through barrels, then reusing them once they cooled, usually after 10 to 15 minutes. So the real limitation wasn't mechanical, it was logistical. Ammo, spare barrels, and support. And those weren't always guaranteed, especially forward. On the Western Front, the Lewis gun proved its value in defense. By 1917, British infantry sections typically had 1 Lewis gun per squad, giving them organic automatic firepower. Its portability meant it could be repositioned quickly, which was huge in fluid battles. Crews learned to prepare multiple firing points so they could shift positions and present unpredictable fire patterns. And psychologically, it mattered. The sound of a Lewis gun and that big pan magazine were instantly recognizable. German assault tactics adapted, often prioritizing Lewis gun positions before attempting to close with infantry. In the engagement near Amiens in August 1918 was textbook Lewis gun employment. The crew had a prepared position, clear fields of fire, plenty of ammunition, spare barrels, and a secondary firing position. As the German attack developed, the gunner engaged at maximum effective range, firing controlled bursts into massed formations. The assistant gunner managed ammunition and kept an eye on barrel temperature. After around 600 rounds, the barrel was changed, and they kept going, steady, methodical, magazine after magazine. German forces tried to suppress the position with rifle fire and artillery, but the stone farmhouse held. When the primary position became untenable, the crew shifted to the secondary and never stopped firing. The sustained fire broke up the assault, forced attackers to take cover, and prevented coordinated rushes. Eventually, the attack stalled and withdrew. Compared to German light machine guns, the differences were clear. The MG08/15, introduced in 1915, was basically a lightened MG08, still water-cooled and weighing about 18 kilograms with water. It could sustain fire longer, but it wasn't very mobile. It needed 3 men and was hard to move quickly. The Lewis gun, lighter, 2-man crew, gave tactical flexibility that compensated for lower sustained fire. German doctrine favored fixed suppressive fire. Allied doctrine increasingly favored mobility and shifting positions. Both worked, depending on the situation. The limitations of the Lewis gun were real. The 47-round pan magazine meant frequent reloads, and those pauses were risky. The pan was also fragile, and the spring needed careful maintenance. The cooling system demanded discipline, and crews who ignored it paid the price, often at the worst possible moment. The open bolt design meant sensitivity to dirt, especially in muddy trench conditions, and required frequent cleaning. Compared to the Vickers, it needed more attention. Production exceeded 100,000 units during the war, making it one of the most widely used light machine guns of World War I. It stayed in British service into World War II, gradually replaced by the Bren after 1938. Variants were produced in multiple calibers, used by many nations well into the 1950s. That longevity kind of proves the design worked. Post-war analysis made one thing clear. The Lewis gun's effectiveness didn't come from superior specs. It came from tactical employment that respected thermal and logistical limits. Crews who understood the barrel heat cycle and managed it properly achieved defensive effects close to heavier weapons. Crews who didn't lost guns and momentum. It's a pretty clean lesson. Technology matters, but discipline matters more. The British machine gun crew near Amiens, who fired over 10,000 rounds in 40 minutes, survived and withdrew when ordered. The Lewis gun itself was probably worn out, barrels shot, feed mechanism degraded, and that was expected. Weapons pushed that hard were usually replaced, not repaired. Their action was recorded in war diaries, but never really publicized, because things like this happened every day in 1918. A battalion was held off by a light machine gun, and two soldiers who understood exactly what their weapon could do, and, just as importantly, what it couldn't. And that's really the point. It wasn't some miracle weapon, or cutting-edge engineering, or overwhelming technology. It was understanding. Two soldiers who knew their machine gun inside and out, who knew when to push it and when to let it breathe, who knew that restraint at the right moment was just as powerful as firepower. They didn't spray blindly. They didn't panic. They didn't chase the rate of fire. They paced it, managed heat, rotated barrels, and stayed alive long enough for the weapon to do its job. In the end, the Lewis gun didn't stop a battalion because it was exceptional. It stopped a battalion because it was used exceptionally well. And in a war filled with massive artillery, grand offensives, and industrial slaughter, sometimes the outcome still came down to a ruined farmhouse, a steady rhythm of fire, and two men who understood their limits and never crossed them.